Hi, welcome to the Data Platform Virtual Summit. I'm Rob Richardson, and we're going to talk about a database DevOps pipeline. What makes it different from an application DevOps pipeline, and how do I get started? Here's the part where I tell you I am definitely going to post the slides on my site tonight. I've chased similar speakers trying to get their slides, which is why we can head to robrich.org. Let's go there right now. And we'll click on Presentations at the top, and here's Data Platform Virtual Summit. The slides and the code up on GitHub are online right now. So that's great. While we're here on robrich.org, let's click on About Me and learn about some of the things that I've done recently. I'm a Jetpack developer advocate. If you're struggling to deploy to Kubernetes, I would love to learn with you. Microsoft has given me some awards. I'm a Docker captain, a friend of Redgate, and AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver the completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for AZ GiveCamp, or if you'd like a GiveCamp closer to you, hit me up on email or Twitter, or follow me here at the conference, and let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, Pro Microservices in .NET 6, that was a lot of fun to put together. SQL Source Control Basics, I enjoyed that book too. And one of the other things that I really enjoy, I replied to a .NET Rocks podcast episode. They read my comment on the air and they sent me a mug. Woohoo! So there's my claim to fame, my coveted .NET Rocks mug. So let's dig into a database DevOps pipeline. We talked about this guy. A database DevOps pipeline. Let's first start with, what is a DevOps pipeline? The goal of a DevOps pipeline is reliability and consistency and cost. Now, there was a time when it was more effective for us to read through our punch cards, do all of the code in our head, to avoid using that really expensive computer. But those days are not today. Today, computers are cheaper than people. They're also much more consistent. They don't forget steps, they don't get distracted, and so anything that we can hand to a computer is a lot better, a lot more durable, a lot more effective. So, we want to automate all the things. If we can automate more things, leverage computers rather than people, then we can increase the reliability and cut the cost. That's excellent. So a DevOps pipeline is fulfilling that goal of creating that automation to avoid the increased cost of people and increase the reliability and consistency of the build. Let's take a look at a typical DevOps pipeline. Now here's a DevOps pipeline for applications. You'll notice that it starts with users and ends with users. If users aren't a core function of your DevOps pipeline, I would invite you to add them. Because really our goal as developers is to build value for users. So if we don't include users in our DevOps pipeline, what are we doing? We start with a customer suggestion. Maybe that goes in a task tracking system. As a developer picks up that task, they're going to modify some code, submit that code into source control, and that'll kick off an automated build. Now this automated build will build all of the things and may run some unit tests. Once it's done, it'll probably deploy it to a non-production environment where we can run some additional tests. Once we've identified that this build is okay, we'll deploy it to production. And now once in production, we can get customer feedback. This is excellent. Now, we may have some concerns in this DevOps pipeline. Maybe a unit test fails. Now, if a unit test fails, then we'll stop at this point, take the learnings from that failure, and see if we can adjust the things. So in this case, we bring the code back to the developer can make some adjustments and kick off a new build. Now that's great. We'll probably end up deploying this to a system where we can track the versions across the various properties, and we have a really elegant deployment system for applications. Now, how does this work for databases? Well, we probably do something like this. Over the course of developing, we'll create some SQL scripts that'll do some things. When it comes time to deploy, we'll probably look through the list of SQL scripts, we'll run them. Some may fail, some are obsolete. Sometimes we needed to rework them. Now, we're probably deploying late at night so that we're not impacting users, which means we're tired. We have SQL scripts of unknown origin. We have developers who are exhausted and therefore prone to errors. This is not the consistent, reliable, cost-effective automation that we're looking for. Yeah, this is an area ripe for mistakes. We have scripts of unknown origin. We have a late-night developer trying to mash them into place. Unfortunately, this is the state of the art today, but it's really not great. Yeah, it's typically a manual process. We connect to the remote server. We run some scripts. Where did those scripts come from? Have they gotten run before? Do they need to get run in this environment? We don't know. And the developer is tired. Yeah, that's kind of intense. It's a perfect storm to make lots of mistakes. Now, this is very different from the DevOps pipeline we had for applications, where we could do some really wonderful automated processes to quickly deliver value from user suggestions into user features. Here, it's not uncommon that we'll make a lot of mistakes. If you ever gotten on that call on Friday evening and we're going to deploy all weekend, and by Sunday midday we're just exhausted, but we're still trying to plow through so that it can get up in time for work to begin on Monday morning on the East Coast? Yeah, let's not do that. Now, as we look at the database pipeline, as we look at the DevOps pipelines for databases compared to applications, the database pipelines are a little different. Now, in an application DevOps pipeline, once we finish, we blow away the production results and we install a new version of the application. We can't really do that with databases because, well, users get kind of grumpy when we just, I don't know, destroy their data. So, yeah, we can't blow away the database and start over. Instead, we need to care for data through the transitions to ensure the state is maintained. Now, as we care for this customer data, we'll migrate it from one version to another, rather than just wipe the slate clean and start over. The other thing that makes database DevOps pipelines different is the deployment mechanism into different environments is also different. Now, we have production, that's probably very well known. We might have pre-production servers, dev and test servers, QA servers, maybe staging servers. But we also have a local developer setup. We probably don't even think of a DevOps pipeline for local developers for applications. You know, after all, that's git pull. But with databases, where we need to care for data through these transitions, we do need to take extra care to ensure that the database gets from where it needs to be, it gets from where it is to where it needs to be. We need to care for that data through these transitions. So, let's take a look at a DevOps pipeline that we might do for a local developer. Now, if we're just trying to get the latest schema changes, then we probably do a git pull and then run some scripts. We probably need to make sure that we're running them in the right order. We might need to adjust them slightly for the data that we have in our database, and then maybe fix up the data to match the new schema. Now, this is quite a manual process, but that's the process that developers do when they try and keep their local database up to date. Now, by comparison, we may say, okay, no local databases. That may make the problem worse. Imagine that I come in the morning, I open up the shared network drive, I open up my IDE, and I start working. You come into work, you open up the same shared network drive, you open up your IDE, and you start working. Yeah, we're going to really easily collide. Maybe I'm halfway through coding a function when you push build. The same thing happens if we share a database. So we really do want a local developer database, but it does mean that we need to keep it up to date. Now, this is for schema updates. That was pretty easy. What about if we want to do data updates? Now, maybe as a developer, I just kept pounding on this one feature and I got to the point where the feature worked, but now I have, 29 or 59 copies of the bad data in my database, so I need to get up to date. Or maybe I forgot a where clause and suddenly my table is empty. Well, how would we get new data? Well, let's go pester the DBA. Hey, DBA, can I have a copy of the production database backup? Well, of course, the DBA is busy doing production things, so next is wait. And continue waiting. It's been long enough. Let me pester the DBA again. Okay, now the DBA is going to maybe jump in, or maybe we have to wait some more. And ultimately, the DBA will get us a production database backup. We'll restore that into place. And now we need to migrate the schema to the latest version. All of the features that we've built that we haven't deployed yet. So we're back here. Get the latest version of the schema, run each script in order, maybe modify the data to fit based on the conditions of those scripts. Yeah, there's a lot to it. With just the application, we just git pull. With the database, we need to care for customer data through these transitions, even on a local developer setup. So how are we doing at this automation thing? Now our goal is to automate all of the things for reliability, consistency, and cost. And right now, we've got pretty much completely manual processes. Well, let's build up a database DevOps pipeline. We're going to leverage containers so that we can avoid the need to install software on various environments, and that'll be really helpful as we build up this database DevOps pipeline. So yeah, kind of clearly identifying the problem here, typical database processes are manual. And we can't destroy and rebuild the database in each environment. We need to care for the data through the transitions. So let's take a look at a database DevOps pipeline. Now, in an application DevOps pipeline, we'll probably do these 5 steps. We'll get the latest source code. We'll version our assets. Maybe we bake in the build number or the git hash or the branch name, the details that we need to be able to identify this build. Then we'll build the software. Once we've built the assets, then we'll test them. We're doing all of this in an isolated environment. So if it fails, then we'll just throw away that isolated environment and we don't need to worry about it going forward. But if it succeeds, if we were able to get the latest content, version our assets, build it, test it successfully, then we can start to deploy it to known, valid, good environments. And we're going to do this automatically on every build change. So anytime we change any source code in our application, we'll go kick off the build, which will get the latest, version our assets, build, test, all of this in a neutral environment, in a throwaway environment, and if all that succeeds, then we'll start to deploy to known good environments. If the build doesn't work, hey, no harm, no foul. We haven't touched the dev server at all yet. We can just throw it all away. Now, how might this change if we do this with a database? Well, we want to do these same 5 steps. Automatically on every code change, we want to get the latest. We want to version the assets, the build number, or the git hash. We want to build and test all of this in a neutral environment where we're not impacting any real servers that are more sacred, more carefully managed. If all of these processes work, then we'll deploy to a dev or test server, or maybe a production server. Now, what does it mean to build a database? Yeah, that's kind of weird. When we talk about building a database, ideally we're restoring a database from backup, or maybe we're just starting with an empty database, and we're playing all of these database migration scripts into place to transition this into a new environment. So we'll load up a database, we'll run all the migrations, and then we'll test it. What does it mean to test a database? Well, we can run unit tests inside of our database. T-SQL-T is a great library for moving the tables out of the way, creating a fake table with predictable data, and then validating our stored procedures compute the way we expect them to. Or maybe a lighter weight mechanism is to run the integration test from our application. Our application presumes that the database is just so. So if we run our integration tests from our application, it can validate that our database is able to handle the workload needed by our application. Great. on every build change in a neutral environment, get the latest, version our assets, build, test, all of this in that neutral environment. If it works, deploy to a known good environment. As we look at that process of migrations, there's a couple of choices that we can make here. Now, what's interesting is that one of the terms is actually migrations. So the umbrella term is migrations, but we'll also take a look at migrations within it. That's a little weird. There's two methodologies for how we can migrate a database. Now, one is a state-based approach where we have create scripts. Now, this is great because we can watch those scripts change over time. But it does mean that we need to infer the difference between these create scripts and the database at a particular version. By comparison, we can do migration scripts, a change script that identifies how we need to move from one state to another. Now, the cool part here is that we have a very well-paved path, and we can go straight from where we need to go to the destination. So let's double-click into each one and compare state-based or create scripts with migration scripts or change scripts. First, create scripts. Now, with create scripts, we'll have one script per database entity. So we'll have one for each table, one for each stored procedure. We might even have one for a table's static data. Double-clicking into each one, we can take a look at, here's an example script, the customer table. And so we can see the current version of the customer table at any particular time. Now, with this type of engine, we can watch the scripts change over time. We can use tools like git blame or git file version history to be able to see as columns get added or removed. On the upside, we can watch this history in a really elegant way. On the downside, to be able to apply these scripts requires a pretty intense engine. We need to be able to diff these scripts against a database schema and infer how to get from one to the other. That's pretty heavy. By comparison, we have migration scripts. So we have a folder of scripts. One script is each change. So here I have a list of scripts, and in this case I've chosen to sort them by date. And then in each script, we have all of the changes we need to make. Now in this case, I'm adding a column to a table, I'm altering a table, I'm updating some data. Anything we need to do in the database we can do in the script. And as long as I play them in the right order, maybe it'll work. On the upside, we have a very well-paved path. We can go exactly where we need to go. On the downside, will this script fit? Is the destination database the starting schema that we expected? This migration approach can't account for those places where the database may not fit the expected result. Now, in both cases, we'll probably keep track in a table in the database those scripts that we've run. So as the engine fires up, it can say, what scripts do I need to run now? It'll identify those scripts and then run those in place, both with create scripts and migration scripts. So let's compare them. With create scripts, we can watch that version history. We can do a git file history, and we can see when columns have appeared and disappeared. We can take a very straight road from where we are to where we need to be. We don't need to meander through all of the developer's experiments. On the downside, there are some things that a create script methodology can't handle. If we need to split a column or split a table, all the engine notices is that the new table appeared and the old table disappeared. It will probably delete data. So in some cases, a create script may not be the most optimal solution. By comparison with migration scripts, we can take a very well-paved path, but we have to take each step in that path. Maybe the developer renamed the table and then renamed it back. We're going to need to do both steps. Maybe they renamed the table, added a column, changed the column's name, removed the column, split the column. We're doing each of those steps in all of the experiments that the developer did. On the upside, we can take that very well-paved path. On the downside, if we need to lock the table for each of these operations, this deployment methodology may take longer than expected. We also can't really eliminate database drift. We have to assume that the target database is the way we left it. So if any indexes got tuned or any columns got created, our migration script may not fit. So comparing these approaches, we see some major downsides. With create scripts, we can't account for places where we need to migrate data rather than just creating or deleting columns. With migration scripts, we may take a really long path to get to where we need to go that might cause inefficiencies. So maybe we take a hybrid approach. Maybe we have create scripts, but we have a few migration scripts that we need to run in addition to it. Or maybe we use migration scripts, but we have an engine that is able to script out the easy pieces and keep track of the current state so that we can still get that Git version history. Now, a hybrid approach may be perfect, but it may also be the worst of both worlds. If we have a hybrid approach, we need that stronger engine that is able to diff two pieces, but we also need the lightweight engine that is able to take the meandering path. Maybe the hybrid approach is not the best of both worlds. So with a hybrid approach, we can kind of lean on the strengths of each approach, but we do need an engine that can do both pieces. So now we have to worry about it. What if we run our migration scripts and the create script destination isn't where we end up? Or what if we run the migration scripts, but there's database drift that the create scripts then need to clean up? Yeah, this might be perfect, but it might also be the worst of both worlds. And which should we run first, the create scripts or the migration scripts? As we look at database migration tools, there are a lot of them, both in create scripts and in migration scripts methodologies. As you grab these slides from robrich.org, I invite you to come to each of these blue links and click on them to discover which tools might work best for you. And I'm definitely not here to sell tools, so find the one that matches your methodology, whether it's create scripts or migration scripts. And hopefully this gets you past a blank list, but ultimately choose the one that works best for you. One more consideration as we're looking at tools. Some tools are very database specific. They hone in on a particular database vendor and are able to do very high fidelity diffs across that database engine. But they only work for one database engine. By comparison, we may have database agnostic tools. Maybe they have a plugin model that allows you to put in whatever database type you need. On the upside, very database specific can do high fidelity comparisons. On the downside, it only does it for one vendor. By comparison, database agnostic tools are great across lots of different engines, but they may not have the fidelity. They may not be able to dig into the deep database properties or unusual schema things for a particular database vendor. It's more general and holistic. If you're just sticking to kind of the basic pieces of the database, then these tools are probably fine. But as you get more into specifics of configuring users or roles or extended properties, then you probably need a database specific tool. So the database build process. We want to do these 5 things. Automatically on every change, in a neutral environment, we want to get the latest, version our assets, build, which means restore the latest database version and run all the migration scripts, run our tests. Maybe these are the integration tests with our application. And then, if all of that works in a neutral environment, deploy it to a known good environment. That's the first step where we're stepping outside of our sandbox, and we can deploy that into a known good environment. If the build doesn't work well, or if the tests fail, we haven't compromised anything. We've just done this in the neutral environment that we propped up for the purpose of this build. So let's take a look at some builds. We're going to walk through 4 builds today. 2 with create scripts, 2 with migration scripts. We're also going to walk through both on-prem builds and cloud-based builds. Now, in this repo then are 4 build scripts. You would definitely not put 4 build scripts in your DevOps pipeline, but it'll be nice to be able to explore each one. So choose the one that works for you and extend that one or customize it to do exactly what you need to do. Or if nothing else, just be inspired by it. But this code is definitely available up on GitHub, and you can dig in right now. So here's our code inside of GitHub. We're going to start with an on-prem version of this. So let's pop open that one. Now here's our on-prem version of our database migration script. Now we start out here with create scripts. So here's a create script that identifies the setting table, all of the columns in that. As I modify this table, I'm going to modify this script. The task status table that will give us some lookup data. Now both of these have data that we might choose to keep, so I have some scripts to create that data. And then I have a to-do table that will reference those two. We have create scripts, so as I add additional columns or rename columns, I'll modify these scripts. Then we have an engine that will diff these scripts together with our database and be able to make the changes that we need. So let's take a look at the build script. Now this is an on-prem build script. It's a PowerShell script, but we could do this in a batch file or in a shell script. I'm going to start by saying my error action preference is stop. That means that I don't need to say, well, let's do or exit dash B, the error level. This just says, hey, when you get to a thing that fails with a non-zero status code, just dump out. Perfect. Now I am setting my SA password that I can use in all the places. Then we start by spinning up this local copy of the database, isolated to this neutral environment where we're going to run our tests. Here in this Docker Compose file, we spin up, in this case, SQL Server. Now that's great. We have a database in a neutral environment that won't get impacted by other things. So we'll spin up a SQL Server container, and once that's ready, then we'll be able to connect to it. Now in this case, I'm doing a very naive approach. I'm just waiting 80 seconds. I've seen it spin up sometimes in 20 seconds. I've seen it sometimes take more than a few minutes to spin up. Yeah, I probably should swap this out with something that runs through a loop and tries to connect to the database to wait for it to be available. But this works for now. Once I've got this empty database spun up, now I could do things like restore last night's production backup. In this case, I'm not going to do it. I'm just going to say, go create that database. Now, that's great. We now have a database. We can now do this comparison. So I'm using Redgate SQL Compare in this case. I'm comparing this SQL scripts directory to the database that I created. Now, in this case, I'm doing it with a container so that I don't need to install any tools on my developers' workstations or even on my build agents. So let's spin up this container, mapping in the volumes that we need, connecting to the various things, and I'm very specifically linking it to the DB container, the one that I spun up here inside of Docker Compose. So let's run our schema migrations. Let's also run our database migrations, pushing all of this custom lookup data into place. So for example, here in our settings table, we have an API key, and I also added a build date and git hash so that we can just see that this data ran today. Next, let's version our assets. Now we could use maybe the build number or the git hash, git branch. In this case, I'm going to grab the date from this mechanism. So I'll just set the date into the build date column, row, and I'll change the setting table to set that git hash. Now I love setting the git hash because if anything happens, we can use that git hash to check out the software at that exact version to be able to reproduce the concern. So we versioned our assets. Next, let's run our apps tests. Now we're still doing this in the neutral environment inside the database that we spun up for this purpose. So I'm just going to select some data to validate that I set my settings in place correctly. And then let's run our integration tests. Now the cool part about our integration tests here is that our app is, we've got some apps here our to-do repository, and we want to just run some tests against that. So I've got some tests like, let's go use our to-do repository and get that by ID. Now, of course, if I get by ID -1, I should not get a result. Now, in this case, I'm running this through a Docker file. Now, this Docker file is interesting in that when I run it, I don't run the application, rather I run the tests. And I'm doing that specifically so that I can inject this connection string into place. I have this connection string that has a particular database server, but that's not the server that I'm using in this case. I want to use that one that I spun up specifically for this task. So let's inject, as we spin that up, the specific environment variable that we need to be able to set that connection string exactly to the database that we just built. Perfect. So we're going to build that container, and then we'll run our application's integration tests to validate that the database works as expected. Once we're done, then we'll Docker compose down, destroy that neutral environment, and then we'll deploy it to a real environment. Now, in this case, I have some environment variables set so that I can go reach into that production server. We'll do a similar thing. We'll migrate our schema, migrate our data, and version our assets. So we've got this build script ready to go. Let's build it. Here's build.ps1, and let's fire it up. Now, of course, the first step is to install SQL Server. Not install, to start SQL Server. And SQL Server does take a minute to start up. In this case, I'm choosing to wait 80 seconds. Is that long enough? We'll see. How did I create these create scripts? Now, I definitely could come into SQL Management Studio, right-click, and say Save As. But in this case, I chose to use Redgate SQL Compare, or Redgate SQL Source Control. So I pick my database, and it will just grab my scripts and allow me to commit those into the SQL directory. So with that SQL directory, now I don't need to worry about that. I can choose to commit this content, or I can get the latest changes from source control, and I can apply them to my local database really easily. In this case, that's how I built this SQL scripts directory. Is I just pointed SQL source control at my database and at this directory, and it worked out great. So let's see if our database is ready to go. Go, 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 go. Imagine if we needed to install SQL Server to make this happen. Have you ever tried to walk someone through installing a database? No, the next option down. Nope, go back. Hey, nope, the next one down. Yeah, it's so nice that we're using containers in this case because we don't need to worry about installing a database engine. We just have a temporary database just associated with this experiment. So we spun up our database, and we were able to diff our schema, and these three tables didn't exist in our destination database, so we created them. Excellent. We did some data, we had some static data in place, and so selecting those two, we can see that we now have that content in place. Perfect. So now let's build our application. Now in this case, our application, we're building our application, and we're specifically running our unit tests associated with that. So it looks like that build is working out well. Oh, it looks like we got our database spun up, and we're ready to diff the content. We were able to diff our schema and validate that we had some. So we're restoring our NuGet packages associated with our application. That's working out well. And then we're going to fire up our unit tests and validate that our build works as expected. .NET build, let's see, is our source code going to build correctly? Let's check. Ooh, it looks like our build worked. Excellent. So now let's fire up our unit. Now that we've built our image correctly, let's fire it up passing in the environment variable to be able to get at, to be able to run our integration test to validate that our database works as expected. Ooh, it looks like we've got 3 passed tests. Excellent. Now we're ready to start deploying to a production server. Now we could choose to deploy, but in this case, I'm just going to break out and stop. Now that was great. We spun up a neutral environment. We created a database. We blasted our schema into place, and we ran our application's integration test to validate that it worked as expected. We also versioned our assets, setting the build date and git hash. All of this worked out really well locally. So let's start to upgrade this from a local build to a cloud-based build. Now, the first step that I'm going to do in flipping this over is flip it to a shell script. Similar to PowerShell, set-e will stop automatically if any of the commands fail. I'm going to set my SA password and Docker compose up to be able to create that neutral environment, that database in an unusual spot, so that I can start playing with that in interesting ways. Then I'll create my database, or ideally, restore last night's production database backup. Now, database backup is only as good as the last time you've restored it, so I like to restore it on every build. That validates that our database backup works successfully, and also allows us to test a deployment. When it comes time to deploy this into production, yes, we've run this build a couple of times now. Next, we're going to migrate our content. Now, we're running the same commands to be able to migrate it here, and we'll version our assets, we've seen that before as well, and run our unit tests. Excellent. Now, once we've done this in a neutral environment, we can clean up that neutral environment and start deploying it to a known good server. In this case, pushing our schema and our data into place, and also updating our version information. Now this was great. We moved from Windows to Linux. Now let's move from Linux to cloud. Here's a GitHub Actions build. Now in this case, we're just kind of doing an interim thing. We're going to do this on particular branches. In this case, I've commented out those branches, but we're just going to kind of blast all of that content into place. Here's that script almost verbatim in one task. Now, one of the things that's interesting here is that you can create databases as containers inside of GitHub Actions. I couldn't get this to work. Here's the docs of how to do this with Postgres. I just failed. So instead of using GitHub Actions databases, I'm going to instead use Spawn. Now, Spawn is really elegant. Spawn is a mechanism for creating databases in the cloud. Now, it uses similar methodologies to containers. So I have an image, a template, and then I have a container, an instance of that. And Spawn is meant for test databases, so they don't live for a long time. So let's come back to this script, and we can see as we want to spin up our test database, we'll instead go dig into Spawn to do that. I'm just passing in the Spawn's access token, and that will create my image. Now, in this case, I'm choosing to create an image with an empty SQL database. All else being equal, I wish I could inline this content, but that will just create an empty database. Ideally, I would be using a production database backup. So maybe at the end of the database production, the production database backup, we could create an image that we could leverage with our builds. Now that I've got that image, I'm going to create an instance of it, a container, and that will output a bunch of information associated with that database. So I'm going to take that data and I'm going to build up these environment variables that I can use for the rest of the script. So previously, where I just had hard-coded details inside of this, I'm going to use these environment variables to be able to get at that content. Excellent. Now let's migrate the content. We saw this previously. We're mapping that SQL scripts directory into the container so that we don't need to install these build tools on our build agent. We'll compare our schema and blast our schema changes into place. We'll also compare our data and blast our data changes into place. Let's version our assets by setting the build date and git hash, and then build our application and run our application's integration test to validate that our database works as expected. Finally, if we've done this in a neutral environment and it still all worked, then let's deploy it into a real environment using secrets inside of GitHub Actions. We'll blast our schema and data into place, and finally version our assets. Now, one of the things that we did previously was clean up our neutral environment. So let's do that again here. Spawn, we've automatically configured to blow up in 10 minutes right here. So our lifetime is 10 minutes, but let's also clean it up when we're done. So we'll start by deleting our container and finally deleting our image. And we're specifically doing this if always. If our build fails, we still want to remove the neutral environment. We don't want to leave that database up in Spawn infinitely. Now this was okay, but this isn't very GitHub Actions-ish. So here's our final GitHub Actions version, where we can create that database in Spawn, create an instance of that database. We'll create our test databases, create our test database using the Docker MS SQL Server Tools image. We'll run schema compare and data compare, and we'll get the current date. Now I can't exactly do bash commands inside of this args thing, so I'll very specifically set this particular date thing so that then when I want to go use that, I can set steps.date.outputs.date and that will be able to grab that date that I computed previously. But notice how I'm using the outputs from Spawn to be able to form the connection string that I need inside this content. Now that I've got my content in place, let's run our tests. So I'm going to select all the data out of those two tables just to validate that it's there. Then let's build our app and run our apps integration tests. Once we've succeeded, we can deploy this to a particular target database. Maybe this is dev test or maybe this is production. Set the schema, set the data, and set the version information. And finally, we'll clean up. So let's do this. I have here a database. Let's pull this up in Azure. And this database in Azure currently has no tables at all. So let's run this build to be able to get our tables into place. So let's connect to Azure. Spin up the gerbils. Okay, Azure, we've got some database stuff to do. Almost there. Almost there. Almost there. Azure, we're so close. I've noticed that sometimes it doesn't realize that it's connected, and so I have to kind of help it along. But it looks like in this case, there we go, it's connected. So let's take a look at the tables, and we can see that we have no tables in this database yet. So let's run the build that will do that. Here's this database DevOps pipeline. We'll come into Actions, and we can look at that specific build that we're looking for. Now, not the interim one, but rather the GitHub Actions one. And we'll come in here and we will run workflow. Now that we're running the workflow, it's going to be really cool. Let's come back into, there's our new build. And let's fire up this build. We've got one stage inside this build. And now it starts off by pulling each of those images. Now, it may take a bit to pull the images, but one of the things that is interesting here is that here we're actually not pulling the image. We're actually building and then running the image. Now, the reason that I do that is because here when it's pulling the images, it presumes that all of those images already exist. And in the case of the database, or in the case of the application's unit tests, it doesn't exist yet, so I can't enumerate it there. So that one, I'll very specifically run Docker build and Docker run commands. Here we're creating the data image. Now, spinning up SQL Server does take some time, but pardon me, I'm really impressed at how fast Spawn is able to spin up these images and containers, even with a large amount of data. Now, they're temporary cloud databases, but it's perfect for running these unit and integration tests, for these temporary databases. So we've created our database image. Now we're creating our data container, an instance of this image. Once we've got our database image and container spun up, we'll be able to harvest the connection details out of that image to be able to run those details. So we're creating the container. I love all of the environment variables that get passed into that container. That's just hilarious, all the details that it needs. Now this does take a minute, but imagine the process of installing SQL Server in each environment, on each build agent, and then cleaning up the data afterwards. This is so much easier. Okay, let's create the test database. We've got that in place. Now let's migrate the schema. Now the cool part here is that we're comparing our scripts directory to that empty database. And so we'll identify the tables that are missing in that empty database and just blast them into place. We can see that we found those 3 tables and we set them into place. Now let's migrate our data. Similarly, let's look through all of the data scripts, compare them with all the data in the database. Now because these tables are currently empty, we'll blast those 3 rows for each of the 2 tables into place. Now let's run our application's unit tests. We started off by selecting that data. We can see that both tables have the data that they need. And now we're building and running our application's integration tests. We're storing the NuGet packages for these tests, so Entity Framework and XUnit. Now let's kick off the build. Now I'm not sure, will this application succeed? Will the build fail? Let's see. Go, go, go. Oh, the build succeeded, excellent. Now let's run our integration tests. We very specifically form this connection string here to be able to pass that into our application. So here's this connection string, and we're using all of these variables from Spawn to be able to form that connection string in a really elegant way. So it looks like our integration tests passed, excellent. And so now we're starting to update the real environment. We did all of this in a neutral environment so that if those tests failed or if the schema building failed, we wouldn't impact real systems. But now we're going to do that with our real production database. And so what was once empty, now we've got that build succeeded. Let's come back into Azure and we will refresh those tables. Yep, now we've got that content. So let's come into the setting table and we can see that this build happened right now with this git hash. Excellent. So now if anything happens with this database, we can go back to exactly this git hash and understand the problems that we had here. Now maybe we want to version this with a git branch or a build number. That can be completely fine as well. Whatever version information we need to be able to get from production into our source code to be able to reproduce that concern. So that was excellent. We did 2 state-based builds with these create scripts. Let's now flip over to migration scripts. Now, with migration scripts, we have these various migration scripts that create the data that we need to. So let's create this table. We'll insert some data into it. We'll create this table. In this case, we don't have any data, but we do have a foreign key. We'll create the setting table, blast some setting table data into it. And then, oh, I forgot a column. So let's go add another column into this table. Each of these scripts migrates from a particular state to a new state to be able to build what we need to do. Now let's take a look at an on-prem build. Now, what we'll see in this on-prem build is that for the most part, it's really similar to the build that we saw previously. Let's do a Docker Compose up to build that application, build that database, and validate that that database works as expected. Now that database is just a neutral database that we spun up for this purpose. Not a server that we really care about. It was all done inside of containers. Then let's go create the database, or even better, restore the database from last night's production backup. Now we'll run migrations. Now in this case, I'm using Flyway. Now Flyway has a really elegant mechanism for being able to run migrations. So I can go into my Flyway directory and I can just say Flyway migrate. What's really interesting, if I want to run flyway migrate, I can do that inside this container. So I'll just do that and I'll say, use this image and migrate it. And here's my connection string to that database. Now that I've got all of the scripts that I need to run in place, now I can start to update my version information. So I'll set my build date and set my git hash and then run my integration tests. I'm forming that connection string in the same way, building the application's integration tests and then firing up that container with this environment variable set. Now all that happened in a neutral environment. So let's go clean up our neutral environment. We'll just throw away the database that we created. We've validated that everything works as expected. Now, let's deploy it to our real system. Now this is an on-prem build, but we're still using containers to be able to accomplish that so that we don't need to install any build tools on our build agents or any of the other servers in our environment. Finally, after we migrate our schema, running all of those migration scripts, we'll also version our assets, setting the build date and git hash in this case. Now that was an on-prem build. Let's do a similar thing with a cloud-based build. And you'll see that this is very familiar as well. So let's create our data image, create our data container here in Spawn, and create our test database, or even better, restore our data from a database backup. Then we'll run this flyway action. I love that action where we just pass in our connection string and it just does the things that we need to do. Excellent. We'll grab the current date because we can't run scripts inside of the args part, so we'll set that date, and then we'll version our assets using all of the details from Spawn together with all of the details from this date to be able to set that git hash and current date. Then we'll run our integration tests. We select some data just to validate that it's there, and also build and run our integration tests associated with our application. If our application's integration tests pass, that means that our database was able to support it. And now, since that succeeded, now we can proceed to deploy to a real environment. So similarly, we'll connect to that production server using the secrets that we stored in GitHub Actions, and we'll deploy this content to the real server. We'll also version our assets on the real server, and finally clean up, if always, to ensure that they're always deleted, not only if the build is successful, and we'll delete our container and delete our image from Spawn. So in this case, we were able to look at 4 different builds. We looked at a cloud-based, on-prem based build for state-based things with create scripts. We did a couple of versions to get to a cloud-based build for create scripts. Then we did an on-prem and cloud-based build for migration scripts as well. Now, whichever of these 4 builds is most effective for you, clone that and start to iterate on that to get it to the point where you can start to leverage this database DevOps pipeline too. Now, this database DevOps build process, automatically on every change, in a neutral environment, we want to get the latest source code, we want to version our assets, we'll build, which means running those create scripts or migration scripts. Then we'll test it, probably running our application's integration tests, or maybe we have some unit tests associated with our database. All of that is in a neutral environment. And then finally, if all of that works, we can start to hit a real environment where we deploy these schema changes with create or migration scripts together with the version information into our production database. What's really elegant here is in all of the cases, we restored our production database backup so that we could migrate from there to be able to get to the current version. So in effect, we're practicing a production deployment on every build. When we get to the final production deployment and the DBA is like, well, has this script run? Yes. Here's all of the successful builds where it's run perfectly. So at that point, we have a high level of confidence that this will work moving it into production as well. We're not doing this late at night. We don't have a list of scripts of unknown origin. We have a great automated process that will do this automatically on every code change. We can sleep easier. Database DevOps. It is a really elegant mechanism to be able to get the content that we need from where we've created it automatically into those environments, safely and automatically. Database DevOps. You can do this. I'll meet you in that spot where the conference is designated for live Q&A, or if you're watching this on demand, hit me up on Twitter at rob_rich, or click the email button on robrich.org. The slides are available right now on robrich.org, so I look forward to your thoughts. See you there.